Welcome to the Hennepin-University Partnership Webinar Series. Today's webinar is titled Innovative Data and Collaboration, Enhancing Public Policy Decision-Making, and is presented by Dr. Bryan Runck. My name is Sophie Latkins, and I'm a graduate assistant with the Hennepin-University Partnership. We are also joined by HUP Director Amy Delahanty. The Hennepin-University Partnership is a strategic partnership between the University of Minnesota and Hennepin County that aims to connect these organizations at points of mutual benefit. We aim to catalyze research partnerships, engage students by providing experiences that enrich learning and build a future workforce, and share expertise, best practices, and knowledge, something we hope we'll do today. Before we get started, just a few Zoom reminders for our audience. Your video, audio, and chat are not enabled. If you need any support from the HUP team, please use the Q&A function. If you'd like to ask a question, you can submit that through the Q&A function. We will monitor for questions throughout and save time to address them at the end. And this webinar will be recorded. Please look for an email from hup@umn.edu with a survey and a link to the recorded webinar video tomorrow. And finally, we're so glad to welcome and introduce our presenter, Dr. Bryan Runck. Dr. Bryan Runck is the Associate Director of GeoCommons and a Senior Research Scientist at the GEMS Informatics Center at the University of Minnesota. His research focuses on real-time geographic information systems, AI, and machine learning to improve agricultural management and policy. He specializes in integrating real-time data and spatial modeling to enhance decision-making. And now I will turn it over to him for the presentation.
That's great. Thanks so much, Sophie, and thank you, Amy, and everyone at HUP for having me here today. It's been such a pleasure to collaborate with HUP and through HUP. And is everyone seeing my screen okay now?
Yep, we got it.
All right. Yeah, and so it's such a pleasure to be able to collaborate with HUP. And so I've been working with Hennepin through the Hennepin University Partnership now, I think for, gosh, almost 5 or 6 years. And it's just been an amazing institutional infrastructure for me as a researcher to build partnerships and to really be able to deliver on the university's trifold mission. We've had partnerships that are purely research focused. We've had partnerships that involve myself and my students in outreach initiatives. And because of how receptive Hennepin staff are to working with students, it allows us to engage students in the classroom. And so it's really kind of the full package from my standpoint when we think about mission-driven work at the university. So I'm going to get to share about a lot of different subject matters today, and so my background is at the intersection of advanced forms of computing and geographic information science, and then really the agriculture and natural resource sciences. So I collaborate extensively with other experts across the university, and I come at things really from a computational viewpoint. What I want to talk about today is give an overview of how we use real-time geoinformation systems to tackle some pretty challenging problems in food, agriculture, and natural resources. And really, this tagline is the theme that I want to come back to again and again as we go through this talk. We really look at technology and we look at mapping, we look at data science as a way to build coherency among diverse groups of folks and to build a common understanding of what the challenges are in front of people and how people might work together to go about addressing those challenges. I've been at this for about 15 plus years now, building technologies specifically in a co-design approach, trying to address these challenges, and we'll really focus on some of the work that's been going on in the last little bit. So what to expect here going forward? So first, I'll talk a little bit about who we are, and specifically, I'll talk about the GEMS Informatics Center, which is housed in our College of Food, Agriculture, and Natural Resource Sciences. The center has somewhat of a unique mandate when it comes to when it comes to a unit within the University of Minnesota, and that really shapes the work that happens in my lab, where we're focused in on these real-time geoinformation systems. And then I'll briefly talk about this framework that we use called technology readiness levels, where it helps us and our partners understand where technologies are at in the R&D process so that we can really get aligned on our expectations, which I think is one of the challenge areas when we talk about engaged research or we talk about technology intensive or data intensive solutions to applied problems. After that, I'm going to go through and I just want to give some quick examples of where we have done co-development using real-time technologies. And so I'll talk a little bit about our work in irrigation management, talk about some of our work in cover crop management. We have a large project to go into a little bit more depth on related to perennial cover monitoring and management. And then we'll talk about how we also think about this from a sustainable business model standpoint, where really we want to scale up the use of our technologies when they're no longer in a research setting. And we can do that through these service organizations that we have access to in the University of Minnesota. Okay, so after those overviews, I want to do a deep dive on a specific partnership that is a hub-based partnership focused on collaborative natural resources planning. And so this is a project that's been going on for the last really 6 years. And I think it's a cool example of what's possible working with the university and working with local units of government. And then I'll end with some just brief takeaways. Okay, so first off, the GEMS Informatics Center. Who are we? So our mission within the College of Food and Ag is to use data to drive innovation in food and ag, really through public-private partnerships. And so our labs are expected to be directly engaged with external partners, helping solve their problems, their day-to-day problems. And so you can see here we have 5 labs. And then as our research becomes more developed, as our platforms become more standardized so that it's a rinse and repeat process, we then port those innovations over into service organizations. What those service organizations let us do is to deliver software and hardware technologies as a service. And so that means that we can engage with other labs in the university or other research units, or we can go external and we can partner with everyone from nonprofits, large and small companies. And ultimately, most of that work is done at cost, but it allows us to drive forward and support the overall mission through these organizations. So the labs specifically, we evaluate our research topics according to these kind of 4 main criteria. So first, whatever we're going after has to be considered to be a high impact problem. There has to be some novel digital technology involved. We need to have clear and medium term steps to impact. And so when we think about medium term, we're thinking a 3 to 5 year time horizon. And we generally want to see broad support across sectors. And so when we go and we talk with our external stakeholders, we want to be hearing from local, regional government, state government, as well as the private sector that yes, this is a problem. And then what we do is we ask, how can we approach this problem and do so in a scalable way that can have broad impact. My lab specifically focuses on developing applied solutions in geographic information science and identifying and testing generalizable principles related to spatial AI and ML. Okay, so just some of the people that exist in the lab. And so we're a diverse group of scientists and engineers. We span disciplines ranging from electrical engineering and mechanical engineering to we have agronomists and agroecologists and then folks that are more on the data science side. So really it's a diverse group of folks that are all focused on applying these advanced technologies to solve specific problems. Our study system is a little different from, say, what exists in other units within the College of Food and Ag. So we don't we don't necessarily study, hydrologic processes, or we don't necessarily study how to mitigate, uh, the environmental impacts of corn production per se. We're happy to work on all of those problems, and what we're trying to do as we work on those problems is to advance our understanding of these end-to-end real-time systems. And so you can see here, we think about these disparate sensing systems, so from ground to human collect data to UAVs and satellite systems. How do we integrate those more effectively? How do we fuse that data together so that it becomes useful? We think about how we build then real-time models on top of these data systems. How do we display the results of those models so that they're useful for cognition and decision making? And then we can ask questions about decision outcomes. So in certain cases, there's clear better or worse decisions. And in those cases, we want to evaluate whether or not the systems are being used to deliver better outcomes for various organizations. So this is our study system, and we typically partner with other units in the university to peel off different aspects of it. Because we're dealing with technology intensive systems, we rely on a standardized language of technology readiness levels. So this may be useful for folks external to the research process. I find that as we're building out systems, it's extremely valuable to have a common language for how good is this system at achieving its objective. And so technology readiness levels we've adapted this from NASA's framework, and it allows us then to rank a technology as to whether or not it's a 1, an 8, or a 9, and along this gradient. And so 1 being that we've observed the basic principles. Essentially, we can go to the literature and we can find good examples there. 5 being that we have field validation of the system. So we're doing things at a small scale, maybe with one partner, maybe at just a research station. And then when we get into validating applications in context at scale, this is where the work, for example, that we do at Hennepin really it comes into play, where we're putting our technologies in actual business processes, in actual decision-making processes, and then we're further iterating on those technologies to make sure that they are able to deliver in those relevant environments. Ultimately, very few of our systems make it to what we would consider to be a commercially viable system, just because this requires both a really robust set of technologies as well as a sustainable business model. So really we specialize in taking systems from 4 and 5 and then getting them to 8. And often when we get into 9, we're looking at handing off those systems back into the county or to some other entity that can take it forward from there. Okay, so some of the example application areas that we work in, everything from irrigation management, pesticide drift prediction, mesonets, and then turfgrass winter kill prediction. I'm going to go through now and specifically talk about the irrigation example and the winter turf example. So one of the examples of what we build with partners is the irrigation management assistant tool. And so this is a decision support tool that's used by irrigators across the Central Sand Plains region in the state. And what we've done is we've come alongside the soil, water, and conservation districts and the irrigation extension program, and we've supported the build out of the background modeling that drives the recommendations for growers. And then we've also helped further develop the crop maturity estimation. And so we like to, and so we're happy sitting on the back end of these decision support systems. Our partner Respect, which is actually a local consulting firm, they're the ones who are maintaining and developing this front end. And that's just one example of how we're collaborating. What's seamless about that is that we can host a lot of that infrastructure on university servers, and then Respect is able to programmatically access that. So it's kind of the perfect mix of university and then external partnership there. Other work that we have is an example where we can take field images using a cell phone. And then we've done multi-model comparison to evaluate these cell phone images of cover crops to say, well, how good is this cover crop growth? And then from those images, we're able to predict biomass, nitrogen content, and carbon to nitrogen ratio. So the reason this matters is that cover crop adoption is often held back by a lot of practical management approaches. And so the idea is, well, if we can deploy these models on cell phones and it can give growers an understanding of, hey, how much nitrogen credit should we be giving to this cover crop? It then allows them to inform their fertility their fertility decision making for the subsequent year, and then that should make it easier for folks to adopt cover crops. Okay, I'm gonna for the last example, before getting into the deep dive, I want to talk about our work in perennial systems monitoring and modeling. And so this is work that's been done in collaboration with the University of Minnesota's turfgrass program, as well as researchers at University of Massachusetts Amherst, Michigan State University, Iowa State University, among other partners. This project is a great example of how we can bring the full end-to-end real-time systems in a co-development process with partners. And so here you can see for this project, we needed to engage in actual sensor prototyping because the goal was to understand what were the environmental conditions on all of these golf courses across the northern latitudes. It's a major challenge for these golf course greens in many years for golf course greens because of changing climate and changing environmental pressures. The problem was is that the turfgrass scientists did not know what those changes necessarily were as they were in those relevant environments. Now, that's an issue because if they don't know what's happening in on course or in the location that they're trying to do research, they don't know whether or not their field trials are matching all those what's actually going on on a golf course. So we went through and we did sensor prototyping. We moved through a series of this specifically, they wanted to understand CO2 gas concentration in these environments, and so we did 3 versions of that over a period of 3 years. We did lab testing of these systems to validate them. And then we did local field testing to ensure they're resilient and robust. And then ultimately, we grew into a large-scale deployment across many, many locations. And so in order to support this, we had to go through and develop actual new open source logging hardware and firmware. And so here you can see what how these technologies evolve from our version 1 system where we deployed 8 of these and they were just right outside of our back window to then by 2021 being able to deploy 30 of these really across the state of Minnesota. And then by the time we got to 2022, getting to the 3rd version of the system, we're able to scale this across all of North America and Northern Europe. So the point here is that by engaging in co-design, getting in the hands of the folks who are using the technologies, we then iterate with our partners to get to a solution that is serving their needs. This is kind of a picture of looking over the top of the golf course green and how these sensors would get installed. Some examples of what these look like once they're actually installed. Importantly, we evaluated these first in on-station conditions. And so you can see here, one of the major challenges and why this was interesting from a research standpoint, an engineering research standpoint, was that these devices actually needed to be capable of being flooded and iced over. So you can imagine, so you can see this is really just a hockey rink in the middle of the winter. And that's something that we bring into the space is trying to fit these logging technologies so that they're environmentally hardened and so we can apply them to the specific challenges of this deployment context. What's cool about it is and so going back to this theme of common understanding and coherency, is that as we deployed these in partnership with golf course superintendents, they really got excited about how these systems were able to give them insights into what was happening on their golf course, even though they didn't totally track what all the data necessarily meant at that time. They got and it served as an opportunity for engagement over social media, even with researchers in the turfgrass space, and just an example. And then a part of pushing in and doing co-development is we engage through through the existing extension programs or through with our partners programs uh, to do uh, to do education and engagement around the digital technologies themselves. Um, just to get an idea, so I showed the hardware kind of evolution over time previously, and this is an example of what the data display evolution looked like. So this is pretty rough and pretty quick in terms of getting a first prototype out there. From then, we versioned into something that looked like this, and then this is where we are with a stable platform for the system with V3. And this is very robust, and this is what we consider to be at a technology readiness level 8. So it would be considered to be a commercially viable system, but it is definitely robust and resilient enough for it to be broadly used. Um, we care a lot about the system usability. And so one of the major challenges in this winter turf project was that the placing these devices, the logger and the sensors, actually would result in damage to the golf course greens. And so you can see here in this picture where you actually get this tattooing of the golf course green surface. And the golf course superintendents didn't particularly like this, and so we engaged in surveying with them and said, well, what design would be more suitable for what you need to be getting out of this system? And so we just had them rate the system configuration and their preference for it on a scale of 1 to 5. And here's an example of how we showed just that layout. And then we got additional comments from them here. So we gave them 9 different designs, including the current system, which was design number 1. And what that allowed us to do was identify this new design that was design 7. And really what they preferred was having more cup cuts with the sensors, and then they could bury that logger underneath the green surface and kind of keeping everything condensed in one area there. Again, our purpose with this is, and specifically for this, is to illustrate how we're really trying to be responsive to fitting these technologies to the needs of the people that we're working with. And that is my group's ongoing kind of mantra that we keep in mind is what is it that folks need and want in order for these systems to be able to be useful. Ultimately, this has allowed us to scale data collection across all of these locations. And this includes both environmental sensors and cell phone-based data collection. I'm really proud of the work that we've done here, and this system is generating hundreds of millions of data readings every year. Then that's able to drive forward the research. Just to give an example of some of the things that we do on the modeling side of this. So one of the things that going back to the initial question of, well, what's actually happening on all these golf courses? What can plant scientists learn from this? We can take this data and we can do a clustering analysis. And the main thing is we can then go and say, hey, these are the soil moisture and CO2 conditions that are actually happening on these courses. Here's the O2 temperature and light intensity. These are the things that you should be considering when you're designing your experiments to be sure that your experiments are matching what end users will actually be concerned with. We've also, through this project, done integration with satellite-based estimates. We've done this often to gap fill, real-time sensing systems. There's all sorts of challenges that happen when you deploy fleets like this. Uh, Coyotes will eat sensor cables. Batteries will die. Sometimes our collaborating partners maybe will have something accidentally happen to it. And so by fusing all of this ground sense information with satellite sources, it lets us do things like fill in the gaps for soil moisture measurements and get nice fits here for unseen locations. Ultimately, all of this then gets wrapped up into a service organization. And so one of the service organizations I lead at the university is called GEMS Sensing, where we provide as a service to other researchers and to external partners the ability to integrate data from regional mesonets, custom open source loggers, Meter, which is a vendor of meteorological monitoring equipment, and then Lycor. And we just have infrastructure that integrates all that data and then serves it up through a dashboard so that teams can access that or that data scientists can access that. And this project is a good example of it, where we have data from Lycor-based systems. We have data from the Minnesota Department of Agriculture's Mesonet. We also have data from open source loggers that were deployed on farm. All of it then comes into a single dashboard and a single database so that researchers can download that and use it, or so that other people can use it for management decision making. Okay, so what I've tried to do up to this point is give an idea of who we are and what our mandate is, specifically, to be going after high impact problems with advanced technologies. We work to co-develop these technologies with our partners, whether that be irrigators or if it be golf course superintendents and plant breeders. And we try to track progress as we go through this with technology readiness levels so that we level set with everybody how far advanced and how developed is this technology. I gave a few examples. We talked about the irrigation management assistant briefly. We talked about the cover crop management tool briefly. And we talked about the perennial cover monitoring and management. What I want to do now is focus in on one last project, and this is focused on using real-time technologies for collaborative natural resources planning. And so this was done with the Energy and Environment Department at Hennepin, and HUP has been amazing at facilitating and helping support this project. And I really, really have appreciated this partnership as something that we've been able to slowly build from a small pilot with a student about 6 years ago into a larger partnership involving both the county as well as other organizations. So the motivating context for this project really is within the Three Rivers Park District's 2020 comprehensive plan and Hennepin County's climate action plan. So Three Rivers in 2020 had come to a point and they'd said, "Hey, we've grown our parks large enough internally, and now what we really need to do is think about connectivity between our parks, and to think about the connectivity of our parks to other natural systems." And there's also an acknowledgement internally at Three Rivers that 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 while trail networks are essential, there's probably a need for other forms of connectivity as well, where maybe they're not just human mobility focused, but they'd be focused on the movement of various species between park reserves. Complementing the Three Rivers Park District Plan is the Hennepin County Climate Action Plan, which sets out very ambitious goals to be net zero by 2050. And that has all sorts of implications for how natural resources are managed within the county and how specific programs are implemented and executed today. And so it was really around the initial partnership between Hennepin and Three Rivers and the Minnesota Land Trust that they said, "Hey, we're all working on conservation easements. We're all working on ways to conserve and preserve the best and last remaining resources in Hennepin. How can we coordinate more effectively and more coherently with our other partners in Hennepin County?" So from that emerged what's called the Natural Resources Partner Coalition, and It's between the it's led by Hennepin County, Three Rivers Park District, the University of Minnesota, and the Minnesota Land Trust. There's three main goals of the partnership. Is first to work across boundaries, two is to develop tools, and three is to practice bold and courageous leadership. From a research standpoint, I've uh, come back to this idea of what I call the multi-map problem. And so the multi-map problem is that you have all of these different organizations. They have complementary values, they have complementary goals in terms of what they want to do, and they maybe even have complementary tools or common tools that they're using to execute towards a goal. Um, and so this is a specific example, it was published recently, 2024, in Bioscience, that illustrates how when we do this shared mapping and planning for priority areas, so this is an overlay of four large national conservation organizations, priority maps of where they're going to prioritize conservation and preservation. And then what they've done is they've taken the intersection of all those maps. And what you can see here is that 1.8% of the land area is shared between their priority maps. And then there's a lot of area that is not shared. Now, the challenge with this is that by having many different maps for many different organizations, it can result in confusion, particularly among stakeholders who maybe aren't in the weeds on the technical front. And so the challenge that exists in cross-organization work and in work between organizations that have complementary objectives is how can you go about addressing this multi-map problem. So to address this, we've been working through a process that was founded in interviews, little over a dozen interviews from 2022 to 2023. I'll share a little bit about what we learned going through those interviews with folks from different organizations. And then that moved into this spring of last year, the establishment of an annual workshop, regular spatial surveys, and prioritization model intercomparison work to get a handle on this multi-map problem and to really build coherency and common understanding across organizations. We're actively capturing multiple perspectives on where these priority areas should be and how implementation might happen on them. And then that allows us to get to an integrated set of priority maps. And the Natural Resources Partner Coalition also then has an official membership process for groups that want to buy in to this. And ultimately, where we're at now, and in this month even, is we're beginning to act together on these priority areas. And so we worked with Metropolitan Council to ensure that we can get to specific comp language and maps that are in alignment for the minimum requirements for the 10-year plans, creating space for learning about new opportunities, and then creating processes to seek joint funding. And then we are concerned with implementing and tracking process for the coalition. So going back to 2022 and 2023, we went through a process of stakeholder selection, interview guide development, interview structure, which was open-ended, and then analysis. I won't go through all those details just for the sake of time. I'm happy to talk about with anybody afterwards how we do these stakeholder evaluations. But we did learn there were 14 cross-cutting themes that came from that analysis. And from that, many popped out as from across all those interviews. So first, we heard that visualization is needed to help people see what is, could be, and might be. So my technical, antenna goes up there and goes, well, what kind of visualization might that look like? There's a need for a regional approach. Folks said that they wanted to see partners engaged early and often to build trust. And so that, from my standpoint, fits really well with this co-development approach that we take. There's commentary around specific data sets, and then this idea that really engaged in a marketplace for development and wanting to help coordinate folks in that marketplace. Coming out of those initial stakeholder interviews that we led at the university and that our partners came along with, that teed up a proposal that Christine Maurer from the county led uh, to LCCMR that focused on developing the interactive mapping tools, creating centralized clearinghouse for data, and then offering additional training and support. And so what I think is cool about this was that we were able to come in from the university side. We could do some of that initial stakeholder scoping, and we could then think about from a research standpoint, what might we do here? And then Christine is able to take that and use that to go and get funding for what was needed in the county, and then that also supports some of the work that's going on in the university. So what are we specifically doing as on the model comparison on the model comparison front? And so Hennepin had multiple models that they're using to prioritize where they invest in easements, and these were fantastic models that a lot of effort went into to be able to identify these potential areas. What we did was we had graduate students that could come in and they could convert those models from only being able to be done at an individual parcel or on maybe 10, 15 parcels. And we could convert that into a system that could be run across every parcel in the county. We also then went through a model sensitivity analysis process where we could ask things about how sensitive are these models to the specific weighting schemes and to the specific ways that they're built out. Um, and then ultimately allows for us to move into asking about what kind of performance improvements could we see. So from the multi-map problem standpoint, because we're able to start simulating every parcel in the county using the models that have been deemed as valuable by the county and by their partners, we can start to ask questions about spatial invariance, right? So where in the county do we see that there is always a high score, and that you're and that you're going to always see regardless of the specific model configuration. And it's those areas then that maybe represent the best opportunities for for prioritization when we think about working across organizations. And so on the left here, we can see the map for the entire county of the actual model results for prioritization. And then over here is a map where we've simulated 1,000 times different weighting schemes, and it's the variance of those parcel scores. And so areas that you see a high where you see a high score, for example, and low variance, that suggests it's a spatially invariant area where there could be an opportunity. Complementing this modeling work, we also did pre-workshop surveys, and we've asked folks to spatially identify where their corridors of interest are and why they chose those areas. We also asked folks to share about their rationale for what's happened in that area over the past, what's currently happening there, and in the future. We also asked why it is that folks haven't taken action on specific priority areas that they've identified. And really, we heard that capacity was an issue, so funding, maybe a mismatch between the priorities of the organization and the opportunity, or whether or not there's grants, and then a lack of partnerships often. So we get this case where it's pretty clear to certain folks where this is an opportunity, but their organization may not be the right organization to move that opportunity forward. So coming out of those that multi-map comparison, and then we helped host a workshop this last year where we brought together municipalities and other units of local units of government to engage in a collaborative mapping exercise where we collectively identified priority areas. And so you can see here, each group is broken up in the room. They went through multiple structured activities to say, yes, this is a priority area, this is a priority area. And then as each group did that for their subset of the county, it displayed up on the main screen here in real time, allowing for everyone to get a sense of how their small part fit into that larger prioritization whole. Some of the things that we observed coming out of this is that folks identified areas of impactful change that's evenly distributed across the county. They identified these specific areas, opportunity areas, and they identified these general zones of connectivity. So when we did post hoc analysis on this, we and also survey responses, we heard, folks were very eager to coordinate. They wanted more opportunities to work with other organizations to get the job done. They saw a lot of value in bringing people into the same room, and we also saw that people are extremely ambitious in terms of the areas that they identified. So there are many, many areas, and it represents some very large dollar figures when we think about the amount of taxable land. And so, and so ultimately, what that means is that the size of kind of folks' appetite for conservation areas is bigger than what any organization can do, and probably bigger than what even the collective can do. And so that led us into wanting to be more surgical and fine-tuned in helping identify these priority areas. To help with that, we opened a public survey on really trying to build coherency with the broader constituencies within Hennepin County. And this is still open, and anyone in the county is able to add a point and then say why it is that they believe this area should be conserved. This is an old map as of June, and so just giving you an idea of the spatial distribution there. I'm sorry, old map in January for the last slide. So in midwinter, we did follow-up meetings because as you saw in that initial rounds of the initial round of maps, there's just a broad swath of areas. And so in the January and February timeframe, we met with small groups of cities and watershed districts and said, let's really hone in on what are the specific locations where we could look at forming partnerships and collaborating to implement change. And so here, each point is an area that someone in the workshops identified. Yellow are the areas of connectivity between those new areas of opportunity and existing areas. And then the red lines are thematic connections where there maybe isn't a spatial way to connect to those opportunities, but that they're thematically connected in terms of what kind of work would be done there. From that, we're able then to go and combine it with natural language processing tools to automatically identify shared project opportunities. And so this is an example of a clustering analysis where each row here is a specific project, and then we calculate find regions of clusters where the projects are sufficiently similar, where those could be opportunities for grant writing together. We also then are able to do post hoc analysis and ask, well, how spatially coherent are these opportunities? And do we observe a similarity in terms of the semantic content of each point and how close they are together? And what you can see is that we actually see a distance decay in how semantically similar they are, so thematically similar they are, and this pairwise distance. So ultimately, from this, we can construct an empirical semivariogram, and this is more so probably interesting from a research standpoint. but it tells us then what the general range is that these projects might be happening in. And so here it it says, hey, this 4 mile distance is it could maybe be a sweet spot generally when we're thinking about forming coalitions around new projects. It also then allows us to connect specific opportunities and say, hey, if we want to act on this location right here, these are the complementary projects in the county that should simultaneously be considered. We're taking this information into a workshop here in May, and these clusters, and where we're actually going to begin planning out how to seek funding for these priority areas. Um, okay, so there's all of this work. We've got the modeling work, we have the surveying work, and ultimately it needs to all be brought together so it's accessible by the relevant stakeholders in the county. And for this, we're using off-the-shelf technology from Esri, Esri's ArcGIS Online Hub, and using that, we can stitch together all of the different pieces so that the information is available for folks. And as we continue to build out the tooling for all of our stakeholders. So just to recap, so we started off back in 2022, 2023 with interviews. We did our annual workshop, spatial surveying, and did our prioritization model intercomparison. From that, we were able to capture these multiple perspectives on what should be prioritized for conservation and preservation in Hennepin County. We're now working into an integrated map and beginning to take action to implement enhancements to specific priorities that different groups have. So we'll be releasing this hub website here actually this month, and we have our annual workshop in May here, and I believe in a week. We'll continue to work on finding matching grants in order to take action on these clustering opportunities. We have further toolkit development that'll be happening, and then we also have work that is really focused on nature-based climate solutions and evaluating those, and how we can quantify the co-benefits of all of this natural systems conservation and preservation work that's going on. So just some conclusions and takeaways. So, from my standpoint as a researcher, I'm really interested in this, right? How do we take these disparate sensing systems, integrate the data, build real-time models, and then see whether or not that leads to better outcomes? But to do that, we want to take a co-development approach. We want to take a co-design approach that fits these technologies to what our collaborators really need, and to ensure that we're solving problems for folks as we're building these technologies while we're also publishing our papers. And I was thinking back preparing for this, like, well, what have I learned from like the last 5, 6 years about project successes? And I came up with six, and I'd be curious to hear other folks' thoughts on this as well. All of the project successes that we've had, they've started small. And so with really a 3-month timeline. And so like a single semester or a single summer. But in that small project, there was an acknowledgement between all of the partners involved that there could be a 5 to 10 year thing here, and that there's a potential for a 5 to 10 year opportunity. Really, because we were thinking long term while starting small and phasing it, it allowed for us to get our strategic priorities aligned, and so that the applied needs of, say, a golf course superintendent or a plant breeder, or a natural resources organization, that their applied needs could be aligned with the long-term research objectives that we had in the lab. And that alignment, it allowed for common understanding between all organizations. From just a practical contracting standpoint, I think after that initial small start, one of the things that we've done that's worked really well is that even if it's a small dollar contract, having that be a small amount for a longer period of time, and even if that long period of time is like 12 months instead of 3 months, or if it's 2 years instead of 6 months, it forces everybody involved to just be more long term and thinking about partnership. And one of the things that we've done is that because of that long-term orientation between our partners, is that it allows for us to begin to integrate one another into our actual planning and management. And so, like when we're setting an R&D plan, like we're often thinking 3 to 5 years out at a minimum for what we might achieve. And it's pretty powerful when a partner will bring you into their 3 to 5 year planning process and go, well, how can we get these things aligned so that everybody's getting what they need out of the process, and that we're solving both the immediate and the long-term objectives. And I think that really, from a research standpoint, what gets me excited is and what I see get my students really excited is where we can have these like practical deliverables, like, hey, in 2 months, we need to do this thing that's going to be beneficial for the Natural Resources Partner Coalition because it'll give them a map that they need. But then being able to couple that with some of the higher risk reward research that we're doing, like for example, with large language models and this like distance dependence of project similarity. And so mixing this like, hey, we're going to get something done. It's going to be useful with, hey, this is speculative. It'll be an interesting research paper, but it may not turn into something that's immediately useful in practice. And I think that's really like that's really what's been exciting to me about these partnerships, and it's something that I think has allowed them to be successful. So with that, thank you everybody for attending the webinar, and I think we'll take questions now.
As a reminder to our Zoom audience, you can use the Q&A function to ask some questions. We'll give you guys a few moments to type things out.
Well, I think while people are chewing on a potential question, well, one, I just wanted to say thank you so much, Dr. Bryan Runck. This was really informative, both just sort of deep diving and learning a little bit more on the technical side, but also how some of your advice on just sort of the co-development and the trust and the principles of like bringing people along in these types of processes where research and collaborations with local governments are happening across this landscape. So I sort of ferreted some of those pieces away. And I'm curious, sort of on the flip side, where have you seen planning processes where, whether that be internal or sort of collaboratively with multi-stakeholders, where have you seen those kind of processes fail when using research and planning?
Yeah, that's a great question, Amy. And I think that it, it maybe the maybe the way to think about it is if if we're tackling big problems, we should expect a high level of failure. And so I grew up in a small town in southwest Minnesota nearby one of the experiment stations for the university. And the director of that experiment station used to always say to my dad, who then like continually says this to me now, that if 50% of what we're doing doesn't fail, we're not doing our jobs. And we don't mean fail as in like we don't get the work done. We mean fail as in like the applied impacts of the work are maybe not what people had hoped for, right? And so we'll still learn things from those failures. I think from a practical standpoint, though, because of the way that we set up our collaborations, so you think about like a unit of government and the university. And so if you start off with an acknowledgement, hey, we're going to try something new, um, and if you scope that so it's small, so that it's like a manageable amount of risk, then it's okay if it fails, because everyone kind of knows like we're trying something new. And I think that the situation, like I've had a few projects where like we planned them too big to start, right? And um, COVID also did not help some of those projects, but where they were challenging projects to get to the value delivery that that our partners had wanted. So I think like, yeah, so I really think that like slowly growing partnerships, and that's where like a long-term orientation is helpful, because it's like, well, if in the first 3 months, we all learn like, oh, things are not turning out as we thought. It's like, okay, it's like, cool. We'll loop back around when there is an opportunity. Yeah. So I don't know, Amy, if that answers your question, but
It did sort of illuminated like innovation takes twists and turns, and we learn from those things, and building relationships over time is important. So thank you.
yeah, definitely. Someone in the Q&A asked, do you have partners in extension that you work with currently? And yes, I love partnering with extension. And so all of the work that we've done with the turfgrass program and the irrigation work is really, we backstop extension. And so Vasu Sharma, who's the statewide irrigation extension specialist, we push into her programs, and she really is the one who is the content specialist. And same on the turfgrass science side. What's what I like about taking that approach is extension has a bunch of infrastructure set up for how to do communications, for how to engage folks effectively. And you see this from my slides. Like you don't want to give my slides necessarily to a general policy person. And that division of labor can work really well. So with the Hennepin project, the way that we've worked, that I think works really well, is that uh, there are communication specialists in the county. They're phenomenal, right? And what we've done is try to align our work plans so that we have time for those communication specialists to convert it into appropriate form for broader consumption. And I think that that's where it's a good example of where we like to work with those experts that in extension and outreach and engagement. Yeah.
Great. So we're almost at time, so I'll close us out here. A huge thank you to Dr. Runck for sharing his time and research with us. And thank you to all of you for joining us today. Please look for an email from hup@umn.edu with a survey and a link to the recorded webinar video tomorrow. So thank you, everyone.
Thanks, everyone.